Hello, welcome to Chapter 7, Sections 1 and 2 with exponential growth and decay. So, we are talking now about exponential functions. An exponential function has the form y equals a times b to the x, where a cannot equal 0, and the base b is a positive real number other than 1. So your base is b, base. Okay, it's the bottom number, and that number always has an exponent on it that is a variable. Okay, so we're talking about functions where the variable is now in an exponent. That's why it's called an exponential function. Now, if your base is bigger than 1, we have exponential growth. And that's this upward moving graph over here. If we have our base as between 0 and 1, right? So just like when we have horizontal shrinks or vertical shrinks, we're talking about numbers between 0 and 1. So those are fractions. Fractions less than 1, but always positive. We're always talking about the positive version. Then we have exponential decay. And that's when it swoops down like this. Alright? So it falls left to right. Now, if we are looking at an equation, like in example 1, and it tells us to figure out whether we have growth or decay, then we just look at the number. 1.3 for A is greater than 1, so we have growth. Now to graph it, I'm going to show you how to graph it in your calculator when you come to class, but for now, you could just get a bunch of points, like you would from a table. You'd enter it just the way you see it, and you plot those points. So we have 0, 1, 1.3, 2, 1.69, and we draw our curve that we see in our calculator through those points. And there we go. For the second one, for B, we have the number 1/3. Well, 1/3 is between 0 and 1, so this is exponential decay. So we will graph this with our points. We have negative 2, 9, which is actually not on our graph, negative 1, 3, 0, 1, 1.3, and it would continue. And so we're going in this downward motion, just like the graph told us it would, right? We knew that if it was decay, it would swoop down, and if we knew that if it was growth, it would swoop up, just by the pattern. Now, you can use lots of different bases for B. B can be whatever number, as long as it's a positive real number other than 1. So we can use 10, we can use 2, you'll see those a lot, but we can also use this number E. So if you turn over your notes, a special number is denoted by the letter E, also known as the natural base E. So that's where you still have an exponential function, but now you have this number E. And the number E is like the number pi, right? It's irrational, it's non-repeating, never-ending. It is a specific number, and you use it in a lot of real-world things. All right? It's related to this graph right here. Okay? There's a trend that this line follows, and the line that it follows, your asymptote that you would never ever touch going left to right, that's E. Okay? So it's the number that it tends toward as you go further to the right. Now, it's important that we know some properties of exponentials. And you've probably learned about these in the past, but just in case you don't remember, if you have a base and they're the same base and you're multiplying them, what do you do with the exponents? Well, you add them. So e to the 3 times e to the 6 is the same thing as saying e to the 3 plus 6. Well, 3 plus 6 is just 9. So that would simplify to e to the 9, and you'd be done. With division, it actually does the opposite. So instead of adding, we are subtracting. But first, we have to deal with this 16 over 4. Well, 16 divided by 4 is 4. So we're just going to put the number 4. And then we have e to the 5 minus 4. Well, 5 minus 4 is 1. So you can put the e to the 1, or you can just make it 4e. That's the same thing. Now, what do you do if you have a power raised to a power? Well, then you multiply your exponents. So the first thing we have to do is remember that this 2 is also 3 squared. and then it applies to this. So we're distributing it in, but as an exponent. So we have 3 squared, which is 9, and then we have e to the negative 4x times 2. Well, negative 4 times 2 is negative 8. Now we have this rule that says that if you have a negative exponent, you have to make it positive. And we're going to make it positive by putting a 1 over it. So we will have 1 over e to the 8x. But where did that 9 go? Well, that 9 is just going to stay on the top. So this is our final answer. Now, you can graph base e as an exponential function. There is a letter on your calculator. Your calculator knows what e is. So whenever you come into class, I'll show you where to find that. But for now, again, we still have to be able to figure out whether or not we have growth or decay. Now, if you have any other base, you know that you have growth if it's greater than 1, and you have decay if it's less than 1, and greater than 0. Here, it's a little bit different, because e is a number, right? It's actually a positive number that's bigger than 2. So it's not actually the base that's going to determine whether or not you have growth or decay. Instead, we're going to look at the exponent, the number in front of x. So right here, we have x. It is a positive x. If that number is positive, we have exponential growth. So because it is positive, this is growth. And again, what I've done is gone into my calculator and found some points. So we're going to plot these points. We've got something down here, negative 1, 1.03, so, and then we have 0, 3, so we're up here, and we have 1, 8.15, which is way up here. And that follows the trend. It is growing as it goes to the right. It gets bigger. Now, if you look at this exponent right here, that is a negative 0.5x. And all it tells us is that if your exponent is less than 0, in other words negative, then we have exponential decay. So here we have decay because our exponent is less than 0. And once again, we're just going to take our numbers and plot them as best as we can. So we're here, negative 2, 2.72, negative 1, 1.65, 0, 1, and 1, 0.6. And that makes our curve. And it is going down. And there we go. So that's all we're going to talk about for exponential growth and decay for now. I'll see you in class. Bye.